let's find out what the mixed partial derivative of this is. Our end solution is going to be d squared f over dy dx. So firstly, let's do df dx. df over dx. When you're differentiating in terms of x, you ignore or hold constant the y values. So df dx is just going to look at this as differentiated into 3x squared, and then you just multiply it by the y. And then in this, we will use the chain rule to differentiate. If you're not familiar with the chain rule, check out my other video that goes over it. And we differentiate this top term, so we're going to now get y squared exy squared. So we've got df dx. Now we want to find out what what d squared f over dy dx is. The big problem here is do not now differentiate this in terms of df dy. Just take this value and differentiate it as df of dy, and therefore you are finding out what d squared f over dy dx is. So dy over d over dy and df over dx is going to equal d squared f over dy dx. So let's do that. Let's take df dx and differentiate it in terms of y. So this first part is going to be 3x squared. And then the second part, we're going to have to use the product rule on. So this is differentiated, and this, let's now use the product rule. So let u equal y squared, and let v equal e to the x y squared. So u differentiated once would be 2y, and v differentiated once would be 2xy e to the xy squared. We now use the product rule on this, so we will now get 2y cubed x e to the xy squared plus 2y e to the power of xy squared. And now we can add this in. So remember, it's this plus all of this. So we're now going to get d squared f over dy dx, which is going to be 3x squared plus 2y e to the x minus xy squared. And then I've now factorized this out, xy squared plus 1. So I've cleaned this up by just factorizing out that common part. So steps: differentiate this in terms of x, you get that. You differentiate this in terms of y, and then you have your solution for d squared f over dy dx.